In this video, we are going to continue our work on graphs, looking at key features, and we're going to finish up the notes for this section. All right, let's talk about end behavior. So this is the notation for end behavior, and this might be new to you, so I wanted to take a minute to talk about what that means. All right, so this says x arrow infinity. The way you read that is as x approaches infinity. This little arrow is approaches. As x approaches infinity, which means I'm heading this way to the right. And then this question is asking me, what is y doing? Which way is f of x going? Remember, f of x is just function notation for y. So as long as y is a function, f of x and y are the same thing. What's going to go in this blank is always a y answer, right? So it might be a number, it might be infinity, but it's always going to be based on y. Okay, now this one, this is read as x approaches negative infinity. Well, here's negative infinity on the x-axis, so this is saying that x is going to the left. So again, as x approaches negative infinity, as x goes to the left, which way is y going? What is f of x doing? So just like before, this is going to be a y answer. It could be a number. It could be positive or negative infinity. If it's going up, it's going to be heading towards positive infinity. If it's going down, it's going to be heading towards negative infinity. All right, let's look at an example. So I have this curve, and I'm going to ask those two questions for end behavior. What is the graph doing at the ends? So as x approaches positive infinity. Okay, so where was positive infinity? Was it on the left or the right? It's on the right. So this is saying as x goes to the right, what is f of x doing? Well, which way is my function going? My function is going down. And you remember that as the function went down, it went towards negative infinity. So the answer to that one is going to be negative infinity. Okay, so the second one, as x approaches negative infinity. So negative infinity on the x-axis is to the left. So we're asking, what is the graph doing as it goes to the left? Well, look at it. This time it's going up. And as it goes up forever, the y value that it is going to be approaching is positive infinity. Notice it doesn't ever say it reaches it. It just says it is approaching. All right, let's try this one. So as x goes to infinity, all right, well, here's infinity over here on the right. What is f of x doing? As I go toward the right, this time f of x is going down. My y values are decreasing towards negative infinity. All right, how about this one? As x approaches negative infinity. Well, negative infinity is over here on the left. So as x approaches negative infinity, as we move to the left, well, this side is going down also. So that's going to be negative infinity as well. So you might have the same answer for both of them. You might have different answers for both of them. You just have to look at that particular function and look at which way the function is going as you head out towards positive and negative infinity, as you head out toward the left and the right. Okay, let's talk about increasing and decreasing intervals. So interval notation may not be something you're familiar with, so I wanted to take a minute and talk to you guys about that. If we have points that are not included in our intervals, and an interval basically just says I'm going from this number to that number, and if those values are not included, we use parentheses. So remember when we talked about our inequalities, we said an open circle meant not included, and that some computer programs allow parentheses or require parentheses. It's the same thing here. So parentheses is just like the open circle. It means it's not included. But if the point is included, if that number that it's going to or from is part of the answer, you're going to have a bracket, which works just like the closed dots that we looked at with our inequalities earlier. Okay, so negative infinity and positive infinity are never included. They are always going to have parentheses, never brackets. The reason why is because it doesn't matter how far you go, you will never reach infinity. You can walk to the right for the rest of your life and you will never get to infinity. So that's why it's not included, because we can never get there. Intervals, except for range, intervals are always, always, always based on x values. Range, by definition, is y values. Every other interval is based on x values. When we read our graphs from left to right. Okay, let's look at this one. So I want to know the intervals where this one is increasing and the intervals where this one is decreasing. Okay, let's start with increasing. So think about just what the word increasing means. Increasing temperature, increasing prices, it just means that things are moving upwards. As you go to the right, the function is going up. So I can see that on my graph here, it is increasing. And I can see on my graph, it starts increasing again over here. So I'm going to have two intervals where this function is increasing. Now remember we said intervals are based always on your x values. So when I look at where my interval is going to start, it's going to start right here at -2. And I'm going to keep increasing until right here at +1. So -2, +1. Okay, so it might be a little bit tricky to figure out whether or not you're going to be including or not including these points. So if you go forward from this class to take physics next year, you'll learn that at the bottom of the valley and the top of the hill, the graph is neither increasing nor decreasing. It pauses for just a second. So for example, if you shoot a toy rocket up into the air, it will go straight up until just for one split second it stops moving and then it starts moving back down again. And so therefore our intervals in this case are going to have parentheses. Those numbers are not included. Okay, but that's not the only increasing interval, right? We've got this one over here as well. So this one starts at 7 and it goes toward positive infinity. When you look at this one, think about the fact that it's going to the right. Don't think about the fact that it's moving up. Up goes with y. X goes with left or right. And so I want to think about the fact that I'm going to the right. Now, just like before, I'm going to have parentheses on that because actually at 7, the graph is changing from decreasing to increasing. It is not increasing or decreasing right there. It just pauses momentarily. Mathematically, in between those, I would want to put a U symbol. What that means is all the points in this interval are part of the answer. All the points in this interval are part of the answer. You remember the U or the union means everything in either set put together. So that's what I have here. I believe on Delta Math, you can just type a comma. So just pay attention to what Delta Math is asking you there. Okay, let's look at decreasing. So decreasing is the opposite of increasing. Decreasing means going down. So again, I'm going to read my graph from left to right, and I can see that it's decreasing here, and it's decreasing again over here. So I have two decreasing intervals. It's not always going to be 2 and 2. It's not always even going to be the same number. It's just that in this case, it happens to be 2. Okay, so let's do this one first. Now remember, we're not going to consider the fact that this is moving up because that's a y idea. We're going to think about the fact that it's moving to the left. As you are coming from the left-hand side, this graph is decreasing, 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 decreasing until I get here to -2. So what's the farthest to the left that my graph can go? Well, that's negative infinity. So notice it doesn't matter that this is going up. Up goes with y. What matters is that it's going to the left because left goes with x. All right, and it decreases all this way until it gets to -2. Because at -2, it's going to stop decreasing and it's going to start increasing. That's why -2 is not included in either one. Okay, so where does it start decreasing again? Starts decreasing right here at 1. You can see it's starting to go down the valley. So it decreases until it gets here at 7, not including either one, right? Because at 1, it stops increasing and it starts decreasing. And at 7, it stops decreasing and it starts increasing. So I'll put the U in between there or perhaps a comma, whichever Delta Math wants to see. And those are my intervals of increasing and decreasing, totally based on x values. So I realize this one looks like a point and this one looks like a point. You're just going to have to work with the context of the question to know whether you're looking at the 0.2 comma 1 or negative 2 comma 1, or whether you are looking at the interval from the x value of negative 2 to the x value of positive 1. All right, let's look at this one. Now we're going to talk about domain and range. I know you've seen those before. Let's just remind ourselves. Domain is all the possible x values. Okay, so we're going to consider all the values that my graph might have as it goes left and right. All right, well, look at this arrow. It is going up, but it's also going left. You guys see how it's tending towards the left right there? And this arrow, it is also going up and to the right. So when we think about the x values, we want to consider left and right. And I can see that this one goes on and on forever from the left to the right. No gaps, no jumps, no skips. So the domain for this one is going to be every possible number. So a couple of different ways I can write that. I can actually write out the words all real numbers. That's a possibility. Or I can use the all real numbers symbol. Some of you guys practice with that on the inequalities. Or if I want to write an interval, it would be negative infinity to positive infinity. All of those mean the same thing. You'll just have to see which one of those Delta Math wants. If this were a paper and pencil test, or if it were something you're turning in Canvas, I will accept any of those three things because they all mean the same. All right, how about range? Well, we said this already, but just as a reminder, range is all the possible y values. This is the only time we're going to consider y values in any of our intervals, and we only do that because range, by definition, is all the possible y values. Well, this one, I can see it starts here at -5. That's the lowest possible value, and it goes forever up. So now I want to consider the fact that these arrows are going up, right? Up and down is with y, left and right is with x. So I can see that this one is starting at -5, and it will go up forever to positive infinity. Well, at -5, do you guys see that the graph actually reaches -5 at that minimum value right there? So I'm going to put a bracket on that, but I still put a parentheses on infinity because I can never actually reach infinity no matter how high up I go. Okay, so make yourself a little note in here. Range is always from bottom to top. If you type that in backwards, Delta Math will mark it wrong. You always have to go from bottom to top. Now, domain is always left to right. And again, if you type it in backwards, Delta Math will mark it wrong. It's always smallest to biggest. So smallest to biggest x values are left to right. Smallest to biggest y values are bottom to top. All right, let's look at these. Let's see if we can find the domain and the range on these. So domain is based on x value. Sorry, I can't aim very well. The domain here is from 2 to 6. And you can see at those endpoints, it's actually at 2 and actually at 6. So those are going to be brackets. All right, now let's do the same thing, but let's look at range. So range is your y values. And I'm going to put some lines here. That right there, right there. It looks like the bottom of that is maybe at 0.5. So I'm just estimating 0.5. And it's going to go up through 4. All right, so there's my domain and range on that one. All right, let's move down here to number 6, domain. Well, look, it's going forever to the left and forever to the right. So I can say that my domain is all real numbers. I can write out the words, or I can use the symbols negative infinity to positive infinity. All right, well, those arrows are going left and right, but do you see how this one is also tending up and this one is also tending down? So the range is also going to be all real numbers. It's going on and on forever, up and down. All right, how about this one? So domain. Well, once again, I can see that it is forever left and right. So the domain is negative infinity to positive infinity. And this one looks a lot like that last one. It's just a little bit more spread out. So the range is also going to be all real numbers, or negative infinity to positive infinity. On this last one, I'm going forever, ever left and right. So the domain is all real numbers.